Good morning. Good morning and welcome to AU Istanbul 2017. I am very pleased to be back in Istanbul and to be able to continue the conversation that we started last year at AU. And of course, that conversation was about the future of making things. Now at Autodesk, we have a very strong point of view that significant trends in customer demand, demographics, urbanization, and of course technology are driving all the industries that we serve to change. There's a bright future out there because of the new capabilities we will have to create higher quality products at a lower cost, to delight our customers and to deliver services that generate new revenue streams. So what are these drivers? In particular, what are the technology drivers that are bringing this future of making things to us? Well, I want to talk about three of them today. First, I want to talk about infinite computing, cloud computing. Second, we're going to discuss the digitalization of everything. And finally, we're going to start to explore the incredibly interesting world of machine learning, which believe me, is going to make everything else we talk about pale in comparison over the next few years. So let's start with cloud computing. But before we go into the future, let's go back to the past. This is the 35th anniversary of the founding of Autodesk, and the 35th anniversary of a little product called AutoCAD. And it's not a coincidence that Autodesk and AutoCAD were born in the same time frame as the personal computer, because it was the founders of Autodesk's vision that the personal computer was creating an order of magnitude reduction in cost of computing and an order of magnitude increase in the availability of computing. And that, they knew, was going to open up new markets, create new users. Prior to that, big corporations and companies were the only ones who could afford the mainframes and the mini computers to run CAD software. So let's fast forward back to 2017, and we have another exponential decrease in the cost of computing, at least order of magnitude decrease, and an order of magnitude increase in availability. And of course, I'm talking about cloud computing. And once again, we recognize that this is going to create whole new markets for us, whole new sets of customers, and more importantly, new kinds of tools that we can deliver to each of you. So what do you do when computing is cheap, ubiquitous, available? Well, you don't just put AutoCAD in a browser, you start to do some really interesting things. For example, creating virtual reality environments where geographically dispersed design teams can come together and explore designs at extremely high level of detail to improve quality and functionality. You use all that compute power to energize generative design algorithms. Now, these are algorithms that have been around for years, maybe decades, but only now is it becoming economically feasible to put 10,000, 20,000, 30,000 compute nodes to work and to generate designs like this automobile chassis that no human engineer would ever have dreamed of, and yet it's lighter and stronger than any design that human engineer would have done. And ultimately, we think that getting your design physically implemented will be like pushing a button. You'll think no more about it than you do today when you hit print and you send your document to a printer somewhere with the full expectation that what you saw on the screen is what you're going to get on the paper. You're going to have that same expectation that what you designed is what will be built, and that digital stream of instructions will be optimized by computer algorithms and artificial intelligence and sent as a digital stream of data to a factory somewhere to be implemented. All right, let's talk about the digitalization of everything. Now, when I talk about the digitalization of everything, what I'm really referring to is that industries that up until now have never seen as part of their core value proposition computing are now starting to use computers both in the creation of their products, their buildings, their infrastructure, as well as in putting smarts in those products and buildings and infrastructure. changing the experience that we have with those products. Where do you see this happening? Well, frankly, everywhere. Let's think about the garment industry, where we now have, for the first time, generatively designed and 3D printed athletic wear, and this is just the beginning. How about the building industry, where more and more automation is coming to the worksite, where the worksite is starting to look like an open-air factory, where we see GPS, laser scanners, drones, and of course, this robot bricklayer here. What about automobiles? In my role as the Vice President of Global Named Accounts, I meet with the executives of the largest automobile manufacturers in the world. And I will tell you, this is the scariest picture you can show them. Because GM isn't worried anymore about Mercedes, and Toyota isn't trying to compete with VW. They're all focused on this right here, Tesla. Why? Because Tesla has reimagined the value proposition of an automobile and turned it into a digital experience where it's the software and the onboard intelligence that creates the value proposition, not just the horsepower and the torque, although Teslas have plenty of that too. And of course, digital everything also means connected everything. Because when you've got the smarts on board the products and the buildings and the infrastructure, the next thing is to have the smarts talk to each other so that products are aware of their environment and they get better over time. They're talking to themselves or talking to you. Traditionally, a product is obsolete the day it rolls off the assembly line. A car begins to depreciate the day you drive it off the lot. But when we connect things, we create value over time. So let's look at some examples of where customers are already using the power of infinite computing, the power of digitalization of everything, to set new benchmarks for quality and productivity in their industries. I'm going to start with a sad story. This picture here is the St. Anthony Falls Bridge. It crosses a river, the Mississippi River, just outside of Minneapolis, Minnesota. And in 2007, the bridge, during rush hour traffic, completely unexpectedly collapsed, killing 13 people and injuring another 145. The highway department that managed the bridge had no idea that the extra lanes they had put on top of it were exceeding its load rating and accelerating the fatigue well ahead of what should have been its useful service life. But the story does have a happy ending. This is the new St. Anthony Falls Bridge. And not only is it beautiful and elegant, it's also incredibly smart. There's over 320 sensors on this bridge, measuring metal corrosion, stresses, movement. There's even sensors that detect ice and automatically deploy sprinkler heads to put de-icing fluid on the bridge. Even the concrete is smart. It has a photocatalytic characteristic that allows it, in the presence of ultraviolet, to convert carbon monoxide, sulfur dioxide, and other pollutants into harmless waste products that just wash off the bridge. Here's another example. This is from the aerospace industry. What we see here is the 787 Dreamliner from Boeing, and starting next year, these planes will start to be delivered with the first 3D printed titanium components. This is really amazing because no industry is more regulated than aerospace, and if 3D printing is coming into the mainstream there, it means it will be available everywhere. In this case, this one component will save $3 million per aircraft and untold tons of carbon because, of course, lighter aircraft burn less fuel, produce less carbon emissions. Here's an example from Norway. What you see here is the Varma 12 power plant. It's the largest electrical power generating plant in Norway, but the plant was over 100 years old and badly in need of modernization. So the multidisciplinary engineering firm Norconsult decided that they were going to set a new standard for digital design and construction. Of course, they used BIM to produce high-quality models for the structure, but they did more than that. They also introduced computative design. Here you see an algorithm helping them shape and place steel reinforcement in the giant concrete housing of one of the turbines. The digital use didn't stop in the design phase, though. On the construction site, they deployed drones. They scan the existing structures so they can integrate the new structures easily into them. And of course, they could monitor the construction progress because they were using cloud technology and tablets and able to compare what was on the ground with what was in the BIM model according to the schedule. Going across the sea from Norway to Rotterdam in the Netherlands, we see the RAM lab, the Port of Rotterdam's Additive Manufacturing field lab, that are bringing 3D printing in an industrial scale to the maritime industry for the first time. Currently, when a ship goes into port for a repair, for example, replacement of the propeller, this is a very expensive proposition for the owners. That ship may be in port for months or maybe even as long as a year, costing the owners millions of dollars in lost profit. But your only other alternative is to stockpile expensive inventories of parts waiting for a ship to break. The answer, of course, is to move to on-demand, on-site 3D printing of industrial scale components. And here you see the hybrid process that RAM Lab has developed, combining 3D printing with high precision milling to produce these giant components without any loss of quality, any loss of strength, any loss of precision. And of course, they're not going to stop there. This same technology offers wonderful opportunities in transportation, in space exploration, in oil and gas refining, all of which need on-site, point-of-demand repair. All right, my last example is one from right here in Istanbul. And I'm sure you're familiar with this picture. This, of course, is the IGA, the Istanbul Grand Airport project. Now, as Autodesk, we get involved in lots of airport projects around the world, and by far the majority of them are refurbishment, maybe adding a new terminal. And those are major projects. Those are big projects. But imagine building the world's largest airport from scratch. Now you've really got to apply some technology to pull this off, especially in the accelerated time frame that this project is being executed against. And it is a massive project. 76.5 million square meters when it's done, 6 runways, multiple terminals. When the first phase is complete next year, there'll already be 90 million passengers going through that airport. That'll put it 3rd largest in the world in phase 1. By the time you get to the final, the 4th phase, 200 million passengers a year, doubling the size of the current largest airport, Atlanta Hartsfield in Georgia. So how are they doing this? Well, the folks at IGA decided that they were going to use BIM to the nth degree. They built the world's perhaps largest 4D model. They're tracking over 30,000 individual tasks in that model. They've already detected over 300,000 clashes in the coordination function. And they're not stopping there because they're producing 5D, 6D, and 7D models. They're going to take that data right through the construction process and into the facility management process. And that is truly leveraging the power of BIM. All right, so we've talked about the growth of infinite computing. We've talked about digitalization of everything. I'm now going to enter our last topic for today, and that is machine learning. And this is a fascinating area. The idea behind machine learning is that we can teach learning algorithms how to get better. We can show them the essence of something like a chair, and they can then go off into computer time and produce tens of thousands, hundreds of thousands of iterations on the concept of chair, and come back with very surprising designs. We can attach those machine intelligences, those learning algorithms to robots, and we can give robots vision. We can close the loop so robots like the one you see here can 3D print structures in the air, self-correcting, learning, and improving their work as they go along, just like a master welder would do. And it's robots not unlike this that are currently building in Amsterdam the world's first generatively designed bridge that's also being built entirely by robots. And that bridge will be open for business and, by the way, instrumented with IoT sensors later this year. We can also take these learning algorithms and we can attack really difficult, computationally intense problems like computational fluid dynamics. If you want to understand the airflow over a vehicle or a building or an airplane, you have two choices today. You build a model and you put it in a wind tunnel, or you spend hours and hours with this complex computational fluid dynamics simulation. But wait, there's now a third option. Machine learning algorithms can observe objects, observe their wind tunnel results, and then predict what a new object they've never seen before will produce in that wind tunnel. They are intuiting the results without any mathematics. That has a tremendous implication for all of us, especially those of us who are engineers and used to get paid for knowing that mathematics. So we've talked about the rise of, or the growth of infinite computing, the digitalization of everything, and now we're moving into this world of machine learning. So what's next? What's the next big platform going to be? Well, I would submit to you what's next is all about the data. Because when we have billions of sensors out there creating petabytes of data every single day, it's that data that's going to fuel the development of further artificial intelligence, generative design. It's going to unlock opportunities that we can only begin to guess at right now. Now, this is such an important concept that we're going to dive much deeper into it. And so I'm going to invite up on stage my colleague, Tom Wujek. He is an author, the author of the book Imagine, Design, Create, and a second book that just came out called The Future of Making. He's also a fellow at Autodesk. So please welcome to the stage Tom Wujek.